This is Mission Control Houston. 58 days, 16 hours, 24 minutes into the 40th expedition to the International Space Station, with the crew wrapping up a packed week of science experiments and getting ready for the station to receive a visiting cargo ship next week. Right now, the International Space Station flying in good shape about 258 miles above the southwestern Indian Ocean, with next landfall in southeastern Australia. They'll be out over the central Pacific Ocean when this broadcast ends in 28 minutes. On board right now, Station Commander Steve Swanson and flight engineers Reed Wiseman and Alexander Gerst have just finished the Cygnus Cargo Conference. They're about to start their weekly tag-up with the astronaut office. Flight engineer Alexander Skvortsov is stowing items in the Progress vehicle that's due to be undocked in about 10 days. Oleg Artemyev is preparing for some exercise, a run on the Zvezda treadmill, and Max Sarayev is working on a Russian protein crystal growth experiment. Today is the 109th day in space on this flight for Steve Swanson, Alexander Skvortsov, and Oleg Artemyev. They're due to come back to Earth in September. Today is the 45th day in space for Sarayev, Wiseman, and Gerst, who launched to the station in late May and will be there until mid-November. The crew on orbit is supported by a team on duty here in the Mission Control Center, the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. The Orbit 2 team on console today is led by Flight Director Ron Spencer. To his right, spacecraft communicator Cindy Kester, working with veteran spacecraft communicator Josh Matthew. This team here in Houston has just finished monitoring an orbit adjustment burn using the engines on the station's Zvezda module. That burn took place just about 12 minutes ago, and station crew members gathered together in the Kibo module, standing by for the engines on the Zvezda module to fire. And as they did, you'll see the result. The burn, which had been planned for next week, was moved ahead to this week to avoid any possible conflict with the Cygnus rendezvous operations and to make sure that the station's in the proper position for rendezvous with the next Progress supply ship, which is due to arrive a little later this month. Today's boost was a 1 minute, 1 second long firing of thrusters on Zvezda, which boosted the station's altitude 0.8 of a mile at apogee, 1.3 miles at perigee. The station is now in an orbit of 260.9 by 256.6 statute miles. That Cygnus cargo craft I mentioned is being prepared for launch to the space station on Sunday. The vehicle actually rolled out to the launch pad at the Wallops Flight Facility on Thursday and was rotated from the horizontal to the vertical yesterday afternoon. You're looking at a time-lapse video of that operation. It's done much more slowly than this. But severe weather at the Wallops launch site has delayed the work of the teams from Orbital Sciences Corporation at the pad to get the Antares rocket and the SS Janus Voss cargo vehicle ready to launch as had been planned tomorrow. So the decision was made to postpone the launch until Sunday to allow sufficient time to do the processing without rushing. The 5-minute launch window opens up at 12:52 p.m. Eastern Time on Sunday to send that cargo ship and almost 3,300 pounds of cargo to the station, and is now due to arrive at the station on Wednesday morning to be grappled with Canadarm2 and installed on the Harmony module. Later this afternoon at 3 o'clock Central Time, NASA TV will carry an Orbital Sciences Cygnus 2 Science and Technology Cargo News Conference that'll be coming from the Wallops Flight Facility. The departure of a Progress supply vehicle was the focus of work in the Russian segment of the station today. Flight engineers Alexander Skvortsov and Max Sarayev started their day with a test of the Toru system. That's the system that permits manual control of a Russian vehicle by a cosmonaut inside the Zvezda module, just in case the automated control system fails. After lunch, Skvortsov returned to packing items that are no longer needed on the station inside that Progress, which will all be disposed of when it burns up in the atmosphere on re-entry. In the meantime, Oleg Artemyev shot more scenes for a documentary about life on the station today. before finishing his first exercise session on the advanced resistive exercise device, and then cleaning filters and screens at air intakes in the Russian modules. Flight engineers Reed Wiseman and Alexander Gerst started their day with science. Wiseman set up the BASS experiment in the microgravity sciences glove box for more burning of fuel samples. The experiment, Burning and Suppression of Solids 2, is designed to learn the characteristics of burning and of extinction of fire in a variety of materials in order to improve fire safety on orbit and on Earth in the future. He took a break from the BASS work to go work with force shoes demonstration. It's an evaluation of a new system designed to measure the loads or the forces on an astronaut's feet during exercise. Information that could help researchers and exercise trainers optimize the effects of bone and muscle strength of the exercise work that crew members do on orbit. This morning, Gerst worked with the European Space Agency's Flying Classroom. That's a series of educational presentations to illustrate scientific principles for students. He did that work, as you see, inside the Columbus Laboratory module. And even when he ultimately did take a break from this, he stayed on theme, conducting a live discussion with students in his native Germany via amateur radio before he went back to work on the Flying Classroom and then later completed an inspection of personal emergency equipment on board. Station Commander Steve Swanson's day has been focused on station maintenance. He kicked off with replacement of an umbilical on one of the express racks that holds experiments, then recovered 2 acoustic dosimeters that had been deployed to measure sound levels in different parts of the vehicle, and then moved on to replacing filters in the water recovery system, which purifies urine and condensation and other recovered moisture on board, changes it into pure water for the crew members to drink. After lunch, the focus in the U.S. segment turned to the Cygnus cargo vehicle. Swanson, Gerst, and Wiseman spent half an hour reviewing cargo operations on the commercial vehicle before getting the latest information about the Cygnus cargo in a tag-up with specialists on the ground. Later today, Swanson and Gerst will have their exercise sessions. Wiseman will go back to the Microgravity Sciences glove box to finish up the BASS operations for the week, and he'll then go and set up the robotic workstation in the lab for potential arm operations associated with Cygnus, and then verify the video routing of the centerline berthing camera system, which he installed in the window of the Harmony module's hatch yesterday. Later on this afternoon, Swanson, Skvortsov, and Artemyev will have a handover conference with the 3 crew members who will be taking their place on board in September. We'll be talking with NASA astronaut Butch Wilmore, cosmonauts Alexander Samokotyaev and Elena Serova. They are all here in Houston to wrap up their NASA training for their mission, which is targeted to start with their launch from the Baikonur Cosmodrome in late September, just about 2 weeks after Swanson, Skvortsov, and Artemyev come home. Now, Expedition 40 began on board the International Space Station in mid-May. It runs through mid-September. when Swanson, Skvortsov, and Artemyev returned home, as we mentioned, which makes this roughly the midpoint of this increment. And today we get an update on the science of this mission from Yuri Gunnar Ramirez, who is the Expedition 40 lead increment scientist. Good morning. Halfway through this increment, has there been a science highlight so far?
Good morning, Pat. Thank you for having me again. We have had the initiation of Expedition 40 with in a tumult of activities. SpaceX 3 was completing its mission, and we wrapped up all of the crossover science that took place during that mission. And after that was completed, we were able to engage in the completion of several, and initiation and completion of several of the experiments that arrived. Like Opals, for example, on the external platform side of the house, we were able to finish all the checkout, activation, commissioning type of activities, and successfully transmitted a data set in a video, a high-definition video, from the station via laser.
Right.
And that was very exciting to see that the technology worked really well. The investigation will continue to understand better the characterization of the atmosphere and how that interferes with the laser communication. And but it certainly is opening up our ability to transmit bigger and larger types of files in a much more fast time.
I mentioned earlier in the program today the work with an experiment called Force Shoes, and this has just gotten started in the last couple of days. What is that about? What are the crew members doing here?
That's right. We have several countermeasure exercise devices on station to keep the crew's health, as most everybody is aware. In microgravity, the body suffers a toll by not having that constant pull of the gravity, right. So we have to work very hard at maintaining that that muscle mass in the bone atrophy prevention. So one of the exercise devices that we have on board is ARED, and one of the pieces that we've been missing is being able to correlate the data of the force that is being impacted as the crew members perform the exercises. And as you mentioned earlier, we will be able to take this data and analyze it and be able to come up with much more customized workout for the crew members, which has a range of applications down here on Earth as well for folks that may need a very specific set of exercise devices.
And they're going to be wearing these shoes that are somehow helping to measure the forces that are being imparted up toward them.
That's correct. That's exactly how it works. And they'll collect the data, transmit it down for the community to review. They will go through a range of pound force measurements and try to characterize how the ARED is impacting that, imparting that load.
There's also a new experiment that's, I believe, coming up on the Cygnus vehicle next week that has to do with the clothes the crew members wear.
That's right. You know, one of the questions that people may or may not think about is we don't really have a good way of doing laundry on space.
We have no way of doing laundry.
There's no washing machine, right? Once you wear an apparel and it's worn to the very end, you have to dispose of it. And there's a lot of upmass cargo that comes up that we dedicate to be able to have the clothes for the crew members. Typically, we use cotton type fabrics, and in this investigation, they're looking at new types of material in these fabrics that are not only lighter in the weight aspect, which can reduce the upmass, but they're also treated with antimicrobial type of
some kind of
substance
treatment
to prevent that bacteria growth. So we are trying to figure out how long can we have the crew members wear these clothes. Will it last a lot longer than their cotton counterparts? And by virtue of the crew member being able to wear it longer and it being lighter, it'll save upmass that will allow us to bring other cargo. But it will also by not having the cotton fabric may also reduce maintenance on station because of all the filters that get clogged up with the materials. So we're looking at several benefits, and of course some of the applications could be down here on Earth. We might be able to have that for areas with remote locations where laundry is not as
Speaking of upmass, the Cygnus vehicle is carrying a lot of different experiments that are coming from students around the world. What kind of things are these experiments looking into?
It's really fascinating to look at some of the descriptions of the students' hypotheses that they've come up with. The range is wide in variety. You have anywhere from radiation investigations to growth of different kinds of plants, impacts on even a jellyfish type of investigation where they're looking at whether or not growing in space could affect the ability of the jellyfish to essentially know which way to go.
Mm-hmm.
It's a navigation kind of system as part of the vestibular system.
Right.
Anyhow, just a really wide variety. Those are just some of the examples that come to mind.
And these are a lot of them being coordinated through a private company that's helping to arrange the flight of all of these.
Exactly. Nanorax, is a company that's bringing a lot of these. We're bringing two types of experiments on Orb-2. One of them are coming in the Nanorax modules, if you would, that will be connected to the platforms on station and will be run that way. And then the other set are run through mix sticks, where the crew will essentially activate them by engaging the mix stick and breaking it through and having those contents mix.
Beyond the things that are on Cygnus, what are the give me two of the other things that we should be looking forward to in the rest of Expedition 40?
Well, we definitely have another education-focused activity coming up with Spheres Zero Robotic. This is a competition that is held annually with students from all over the world, and MIT coordinates that. And the Spheres facility, which we've already seen a couple of other investigations being used for that, will host this Zero Robotics competition.
Mm-hmm.
And I think that'll be very exciting to see that. We're also continuing all of the BAS combustion experiments in a counterpart investigation called Flex-2 that also looks at combustion and trying to understand how to make better fuels out of those. So a lot of that, I did want to mention, we also have the types of investigations that you don't see actively performed in the human body. There's a variety of investigations that are coming up where we only take data from the crew members before they fly and after they
Mm-hmm.
return. And they'll be investigating some of those, and it's interesting because you don't see that happening, and we often forget to mention it. We don't have an activity, we don't have anything that you can directly correlate to that.
But it's another example of the crew members being experiment subjects, even though they're not doing something specific to that experiment during the time they're up there.
Exactly.
Finding out how they're impacted.
Exactly.
Well, looking forward to seeing what comes next. Thanks very much. Yuri Gennard Ramirez is the Expedition 40 lead increment scientist. The Cygnus launch vehicle that we mentioned is out on the pad at the Wallops Flight Facility. The preparations for Sunday's launch is continuing. And the work to get Cygnus ready for the launch didn't just get going when the rocket was rolled out to the pad. Recently, I spoke with Floyd Booker, NASA's Cygnus 2 visiting vehicle lead, about what's required to get these cargo ships ready to go and how far in advance they actually start preparing for any given mission.
Well, the program starts strategically. We start years out. We look at all the vehicles that plan to come to station and the various crews and what science is planned for them. And with that, we develop a manifest for each visiting vehicle. And so it's kind of my job to coordinate and manage the requirements as the cargo is identified and developed and delivered, and then of course installed in the vehicle.
And I expect that those requirements and those manifests change over time.
They don't
change. They're not static.
Right. Strategic is years. Tactical, at about a year, we start identifying mass properties, powered instruments like refrigerators, incubators, different components like that to meet unique requirements for the vehicle if it needs power.
The visiting vehicle lead actually means what? What's your responsibility here?
Well, I'm responsible for, again, meeting that hardware's requirements, ensuring we can fly it safely on the vehicle, ensuring the vehicle has the resources to receive it and get it to station.
In some cases, if we're talking about science experiments, those things are known fairly far in advance.
That's correct.
Years, 5 years?
Well, again, from a year's perspective, is strategic plan. Tactical, we look at within a year.
Mm-hmm.
So for me, I start really looking at the details at a year.
At 1 year.
At 1 year.
And it's, I guess, then within that time period that you're looking at the more mundane things, like maybe clothing and other things.
You're right, because then we have crew. We know what sizes they are and things like that. And then within 6 months, we've identified their food, their clothing, all the science equipment, the things we need to repair and maintenance and service within that time period that this vehicle is going to be on orbit. And so those details flesh out at that time.
The long-range planning is done higher up the food chain, as you
Correct.
say, right?
Mm-hmm.
They're thinking in terms of what we know we're going to need in the long term, but the more planning, the more detailed planning, I guess, is what comes in this 12-month lead up?
Correct. 12 to 6 months.
Does that take a whole year, or would you like more time?
Well, it does. I mean, we have to identify the things for the vehicle. You know, what's the total mass of this? Some things are heavier or lighter than others, and so we develop. And of course, that picture changes as we evolve, as we get closer to launch. If we slip, we may change some of the components that are flying, that are needed in that time frame. So there's some flexibility in being able to move cargo from one visiting vehicle to the other as we really approach the launch window.
You mentioned a couple times worrying about mass properties, and just how specific, how accurate does that need to be? For someone who's not in the business, it would seem like, whether it weighs a pound or a pound and a half, so what? We'd be okay, right? Not so much here.
Well, when you're talking about 3,000 or 4,000 pounds of cargo, it adds up. So yes, we have to. The vehicle is limited to a total amount of mass it can carry to orbit. And of course, we try to optimize and use every ounce of that. And so, yes, we worry about the ounces at the end.
It's not just the total weight then, but it's how it's distributed within the vehicle.
That's correct. So there's vehicle weight NCG concerns.
That center of gravity, right?
Center of gravity of the vehicle. And so as the commercial vehicle folks, when they receive our cargo, of course, we're weighing and measuring the CG of large bags so it matches their models when they install it in the vehicle.
When a Cygnus vehicle, this one or another one that you're working on, when it launches, does that mean your job's over?
No, I'm the lead for the Cygnus vehicles, so I've got a backup that's working the next flight. That's now in October. And then I'm already planning. I'm already in sight 1 year for Orb 4, which is next spring. So we're already planning for that flight, the cargo that flies on that flight.
Does your job end when it gets off the launch pad, or are you still following this one all through the rest of the mission?
I will follow this one because part of taking cargo to the ISS, this vehicle does not return. We don't get cargo back. We actually use it as a disposal vehicle. So we're also looking at what trash is available. So we'll load this vehicle with trash, used components and daily trash from the crew, and burn that up when it returns.
And you've got the same kind of weight and CG worries.
The same worries go into that. Yes, we track every bag of trash, every used ORU that goes in each bag, and we communicate that to the Cygnus guys, and they may tell us that this particular bag needs to be in a specific location in the vehicle for return.
Space even on a returning vehicle like Cygnus is pretty important. Earlier this week during the mission management team meeting, I saw you get called up to give a report on how much space was still available on something that was coming home.
That's true. Yes.
People want to make sure that because they want to get everything off the station we can, I guess.
Correct. Mm-hmm. Correct. So in an ideal situation, we will use every bit of mass we can going uphill, and we'll use every bit of volume and mass we have to throw away trash when the vehicle leaves.
So as you mentioned, you're already working on a future, on all the future Cygnus missions, I guess, from what you say, right?
Well, we do have some ideas of big payloads that fly throughout the life of this contract, so yes. Mm-hmm. But again, we start looking at the details inside of a year.
Be very interesting knowing a little more about how it gets packed when you see it get off the launch pad. Right?
Exactly.
Floyd, thanks very much for a couple of minutes here to give us some insight into what goes into packing one of these things. Floyd Booker is the Orbital 2 visiting vehicle lead. This is a live view inside the International Space Station Flight Control Room. The team here looking over the shoulders of the crew members as they do their work. Steve Swanson, Reed Wiseman, and Alexander Gerst just wrapping up a regular weekly conference with the astronaut office here in Houston. Wiseman's going to go back to work on the BASS experiment, while Gerst and Swanson are scheduled for some upcoming exercise sessions. Now, station crew members spend more than 2 years training for this 6 months in space. Some of that training is actually done 40 feet underwater. This morning, a member of the Expedition 4243 crew is getting some practice on maintenance tasks that she might be called on to do outside the station. Italian astronaut Samantha Cristoforetti is in the Neutral Buoyancy Laboratory this morning with NASA astronaut Randy Bresnik. They're working through some skills training on EVA maintenance. Cristoforetti is part of the Expedition 4243 crew, which is targeted to launch near the end of this year in November. She'll be flying with NASA astronaut Terry Virts and Russian cosmonaut Anton Shkaplerov. Bresnik is a veteran of one space flight on the STS-129 back in November of 2009, a mission that delivered some external logistics carriers to the International Space Station. He's also preparing for another mission. He's going to be the commander of the Nemo 19 mission in September of this year, the extreme underwater environment that is used to simulate the environment on the space station. Cristoforetti and Bresnik in the pool for about 6 hours today, working through training on what it takes to do maintenance work on the outside of the International Space Station. For the crew on orbit, they're a couple of hours away from the end of their work day, the end of their work week. The weekend is scheduled for house cleaning and exercise and private family conferences, but otherwise a lot of off-duty time for the crew. Coming up today at 11 o'clock Central Time, NASA TV will have today's NASA TV video file with news from all over the agency. And then at 3 this afternoon, a Cygnus news conference coming from the Wallops Flight Facility launch site in Virginia. Our next live report on space station activity will be Sunday morning at 11 a.m. Central Time, covering the launch of the Cygnus cargo ship to the International Space Station. This is Mission Control, Houston.